40 through 44. Potatoes are sold at the grocery store in 5-pound bags. You decide to weigh a random sample of 10 different bags. And you find the average weight of these bags is 5.2 pounds with a standard deviation of 0.3. Is this evidence that the bags at the grocery store have a mean weight different from 5 pounds? Okay, we're going to make a 95% confidence interval. All right, how many degrees of freedom do we have? 9 degrees of freedom. Okay, we have 10 bags, so 9 degrees of freedom. What's the center of our interval? Our x bar, which is 5.2. Okay, what's the standard error? It's going to be s over the square root of n, which in this case is going to be 0.3 pounds divided by the square root of 10. So, what's that? 0.095, great. Okay, and then 43. What's the resulting confidence interval? Okay, so we got to go to our table and figure out what the critical value for 9 degrees of freedom is. So 9 degrees of freedom, and we're making a 95% confidence interval. Our critical value is going to be 2.262. So I'm going to have 5.2 plus or minus 2.262 times 0.095. So I have 5.2 plus or minus, I have to do some math. .21. Okay, and so this, on the high end I have 5.41, and on the low end I have 4.99. So what conclusion do we make? So do we have evidence that the bag is different from 5 pounds? No. 5 is within our interval, so we don't have evidence that it's different. Okay. Let's just combine these in the video here. Okay. So 45 through 49. It says a fair die should land showing a 4 1/6 of the time. You roll a die 100 times and count how many times it lands on the number 4, and it lands on the number 4 20 times. Is this evidence that the proportion it lands 4 is different from 1/6? So here, what are our appropriate hypotheses? We want to see if p is equal to 1/6 versus the alternative that the proportion it lands on the number 4 is not 1/6. What is the observed proportion? We rolled it 100 times and it landed on the number 4 20 times, so my proportion is 0.2. Okay. What's the standard deviation in this case? All right. So for a hypothesis test, the standard error, the standard deviation comes from the number in the null hypothesis. So it's going to be 1/6 times 1 minus 1/6 divided by n, which is 100. And so that's going to be I get 0.0372 or 0.373. Okay, that's my answer there. And what is your test statistic? So here we're testing, it's going to be p hat minus the p in the null hypothesis divided by our standard error. So that gives me 0.2 minus 1/6 over 0.0373. And I get 0.89. Okay, so that's my test statistic. And 49 says perform a two-sided hypothesis test. So I'm going to draw cutoff at 0.89 and also look at negative 0.89. And I want to see the total area in the tails. So I could look up either positive or negative 0.89. Maybe I'll look up negative 0.89. And the area in the tail is 0.1867. Which means the area over here is also 0.1867. So my total tail area is going to be 0.3734. That's my p-value.
You multiply it times 2?
I take the tail area and I multiply by 2. That's it. That's going to be my p-value. So I do not reject the null hypothesis. We do not have evidence that the die rolls for any different than 1/6. All right. And that's it for that problem.